Hello everyone! In this new practical reverse engineering video I'm going to show you how to perform reverse engineering of some real target. In this case we are going to take the Windows fibers as an example for implementing reverse engineering. So what we are going to do is a pretty common task. Perhaps we don't know enough about this or that component, or the documentation is partial, or is lacking the answers for whatever we are looking at. And what we do is we search for some specific API to have an starting point to start digging, and then from that we go as deeper as we can to, well, gather as much knowledge about that component that we know. So I'm going to open Kernel Based Dll, which is where the DLL where the fiber functions are actually implemented. So let me open it, leave everything by default, and well, yes, of course, we want to load the symbols for that DLL. And now it is loading, and see you soon after it loads. So we have the DLL already loaded in IDA, and we are going to start digging into it. First of all, I'm going to go to the Microsoft documentation to see what fibers are supposed to be. So, according to the Microsoft documentations, fiber is a unit of execution that must be manually scheduled by the application. Fibers run in the context of the threads that schedule them. Each thread can schedule multiple fibers. In general, fibers do not provide advantages over a well-designed multi-thread application. However, using fibers can make it easier to port applications that were designed to schedule their own threads. Well, actually, or at least myself, reading that documentation, it is not absolutely clear how they work from inside. But the good thing is that we have some APIs to start digging from, like convert threads to fiber or create fiber. Create fiber looks like the specific entry point for our work. So this is where is it, the documentation for the function, create fiber. And if I open a kernel base in IDA, it's because I know that it is supported by Kernel 32 DLL, and nowadays in Windows 10 many functions that aren't in the proper Kernel 32 DLL are actually implemented in Kernel Based Dll. And, well, this is the case. Okay, so what we are going to do is open create fiber in IDA and start digging from this point. So double click on it. As we can see, the create fiber is simply calling create fiber X. So let's go to that function. And well, it is not too complex, but complex enough as to better switch to the decompiler, which is much easier. So I will try to do, at least for this function, not very fast, and I will try to go step by step and saying every shortcut and everything that I'm using, so you can do it yourself later. So we have this very first thing that we have to rename v6 because it doesn't tell us anything. It is called also, it is assigned from DW flags, so we could try pressing equal, the equal key, to map this variable with DW flags, but IDA says that it cannot, so what we are going to do is rename it by pressing the key N, and then I'm going to leave the same name. It will complain, of course, because we already have a DW flags thing in our local function, but we don't mind. Okay, later on it checks some mask over the DW flags, and if it passes the check, then it says to v14, whatever it is, the value 87, which is pretty magical, and then it calls RTL set last win32 error. Well, now we know what is that. This is the win32 error, and now we know, just in case, I press N over that variable to put a name. And now we know that this 87 is the error code. If we press the key M, IDA will show us a list of enumerations, that constants that match this one. If we select new and then press enter, all of the constants that are in the current database that matches that value will be shown. In this case, we know that it is some kinds of error. So if we simply write error, at some point we will see that error invalid parameter, which is the one that we want. More things is this label is actually for going to RTL set last win32 error. So we are going to rename it by pressing the key N, set last win32 error. Okay, we have the very first part. So far, so good. Then we have a call to RTL allocate activation context stack. We know that many functions, or at least I know because of experience, that most NT functions and RTL functions are actually NT functions, NTDLL supported functions. They return some kinds of status. So we are going to rename it as status. Okay. If we press the key Y, we will see that it already has the proper prototype, NT status. Then it checks if the status is smaller than 0, and if it is, it calls a function called base set last NT error. Well, as we can see, there is a casting of the status, sending it as parameter to this function. We are going to fix this. To fix this, what we do is press the key Y, and now we know that that first argument is not keyword, but empty status. And we can even set a name here, empty status. Okay, and we got rid of the casting. So far, so good. Let's continue. Let me close this for a second. Yep. Okay. So now we have RTL allocate heap, which is kind of a malloc. And then it says if no memory was allocated because of who knows, then we call free activation context stack and set the win32 error to 8. Again, as we did before, over the 8 number we press the key M, and it recommends now error not enough memory, which makes a lot of sense, which is actually what happens here. Okay, so we know how to do some of the most basic stuff right now. Then we are going to keep renaming things and discovering things at this local function. The next one is RTL create user stack. Most likely that user stack is not the user stack but a status. So I'm going to rename it as a status. Why I know that it is most likely a status? Because most RTL function actually return an NT status. Okay, so I try to rename it as a status, and it is complaining that there is a local variable already existing with this name. That's fine, so press yes. And now what we are going to do is, maybe this status variable I can map to the previous status variable. Instead of having a status and a status 1, status 2, status whatever, we can, in most cases, map them. So I'm going to press the key equal over the status underscore 1, and here we are. Yes, it is recommending us to map that the status 1 variable, local variable, to the status 1. And now instead of having 2 local variables, we have a single one. Much better. We don't know about that DB word. I'm going to ignore for now that call. We will eventually discover what is it doing or the name of this stuff later. So if the status is higher than 0 or equal to 0, we suppose that it is because it is doing properly what it's supposed to do. And then we have, it takes the allocated memory plus some displacement and initialize memory or performs assignments of some local variables or initial values. This is an structured initialization. Every time you see this, you know that it is either a structured initialization or a class initialization, which is basically the same at this level. So what we are going to do is click on HEP, right click on it, and then choose from the pop-up menu, create new struct type. Okay, unfortunately the dialog, we cannot change the font, so you are going to see it very small. But the only thing that I'm going to do for now is, it says that it is something about fibers, right? So I'm going to call it fiber buff tip. Simply rename for now the struct name that either recommends us when trying to create one. So do that and then press OK. And here we are. We have now a struct, and we have some members for the initialization for the segments that we saw here. It is much better than having a memory buffer, a raw memory buffer with some displacements. Okay, let's continue. If we see some memset over some fields and then with some address, it is clear that, or it's most likely clear that the size of that member is actually the one that we are seeing here. So what I'm going to do is, over that member, press the key Y, and then we are going to change it. Again, the font is not changed for everything in the IDAS GUI. It says the prototype, which is char, and the name char30. So what I'm going to do is change it to char and put a size of 0x40 bytes in hexadecimal. Okay, so press OK. And now it says memset hep the field 0 is what we initialize to, size of hep char30. Much better. I don't like the name of char30, so I'm going to press N, remove everything, and now the field 30 looks a bit better to me. Okay, let's continue. We have another member here, char0, and it gets initialized to LP parameter. Well, we know the name for that member at least, so press the key M, LP parameter. And we know also the prototype. If we press the key Y over LP parameter, we will see that it is LP voice. So we can copy it, press Y over the member, and set the LP voice type. And we got rid of yet another casting. Okay, so far so good. Then more things that we can rename. So V17, I don't know what it is, V18 neither, V12 or V19 neither. We can get rid of the V19 variable by pressing key equal, sorry. If I'm not wrong, yeah, we can. Much better. But still, we don't know what is that. Then we have stack. Okay, so we know that we can rename that member, press the key N over it, and set the name to stack. And now we press the key Y here, and it says that the prototype or the data type of that stack local variable is p-activation context stack. Perfect. We know which is the prototype for that struct member. Okay, p-activation context stack. Perfect. Now, more things that we can rename. We have, for example, here a rare thing. It takes the hep and then source it with some global variable called basep fiber cookie, and then it sources it with hep member QWords10. I have no idea about what is it doing here. I just know that it is starting something with a cookie, so I'm going to rename this member by pressing M to source cookie. Call me original. And well, later we have an it is accessing a member inside, or it is accessing inside the member field 30 that we initialized to, that we set that the size was 1232 bytes in decimal. Well, it is initializing or trying to assign a value inside a member inside that hep chunk. The thing is, when it is doing memset, it is probably initializing a whole struct inside that struct. And then we still don't know about the members of that struct inside that initial struct. What we know for a fact is that it is doing something with the flags. And then we have some magic number here, 0x100008. Well, it's not from the top of my mind, I don't know what is that, but maybe I don't know. So let's press the key M and say yes that we want to search for denominations containing that value. So press the key Y, And well, the first one that it recommends us is context floating point. Does it make sense with anything that is going to do? If we take a look here, the next call is going to be base initialize fiber context. It makes a lot of sense. So we are going to choose context floating point. What is it doing? We have no idea, but it seems that that bit, the bit 1, if it is set in DW flags, is for doing something with the floating point context. What it does is what we are going to discover now in base initialize fiber context. First of all, before actually entering this function, I believe that the very first member is actually the context, the thing that is going to initialize. So I'm going to rename it by pressing N to fiber context. Okay. And now we should change also the prototype, the function prototype of this function, base initialize fiber context. Because by default, everything will be set to keyword, 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 keyword. Because IDA doesn't know the prototypes of this function. So what we are going to do is, we know at least the prototype of LP parameter, the data type, which is LP void. I'm going to copy it. We also know the data type of LP start address, which is LP fiber start routine. I'm going to copy both. And we know nothing for now about the B17. We will discover eventually what this does. So with these two ones that we already know, let's press the key Y. And well, we can set the name and the prototypes of at least the two first arguments. The second and the third argument. And for the first argument, we don't know the type, but it is most likely some kind of pointer to what we rename to fiber context. So let's press OK, and so far so good. Time to go to base initialize fiber context to this function to see what is it doing. Okay, here we are, and as we saw before, we have another struct that is being initialized to 0 with a call to memset. And then we have some assignments. We have some raw memory address, some pointer, and then it says pointer plus 12, pointer plus 13, pointer. If we see it, it is initializing some struct. So as we did before, right click over it, create new struct type, and now we are going to simply rename the name that IDA offers us. Yes, I know it is very small because changing the fonts seems not to change in this dialog. The only thing that I'm going to do is set the name to fiber context T, and that's all. And well, here we are. Now we need to rename many other things because the word 30 or the word 118 doesn't say anything to me. Do we have enough information to discover anything here? The first thing that I'm going to do is I'm going to press 8 here over this number, and this 10000B looks like some flag or something magical that maybe in the IDA database we have. So let's press M as we did before, and here it is, the context full. Yes, we are in the function base initialize fiber context, and it is recommending us for this member the value context field because it matches to this value. It makes a lot of sense. So maybe it is something like this member context flags or something like that. This is how I'm going to rename it. Later on, it takes the current pip and checks the member bit field, and it checks against the value 4. It's checking the value against some flag. I'm going to cheat a bit and go to another place to copy or to have the enumeration for these flags. Just a second. So the field, bit field tip, as I call this enumeration, has the following values. What I'm going to do is copy this and insert it into our IDA database. So let me go back to IDA and then go to View, Open Subviews, Local Types, and here I'm going to right click, insert, and just paste that enumeration that I created somewhere else. Then we press OK, and well, the last thing, the last enumeration that we have here is the PEP field it that we already create. Why we created it? Because this flag here is this value. Pressing N, now we will have is legacy process. In the PEP field T enumeration, it matches with that. And well, that's it. In case the current process is a legacy process, whatever it means, so it performs some calculation with the timestamp counter and some magical value. I know nothing about that. I'm going to call it some magic value. And well, okay. And now we need to fix some more stuff. So for example, here for the fiber context, we have one assignment, to gap 44 at 60. This is totally wrong. It means that at this address we have either nothing or we have some big chunk of our memory, and it is accessing to it by doing displacement. This is not what we want. We want to have a proper field like the context flags. So we are going to fix this, but we are going to fix this at assembler level, which is the best part for doing actually that. So what I'm going to do is I will click somewhere where I have the struct that I want to properly have, and in one member, for example, context flags. Then press the key tab, and here we are. So it seems that what we are looking at, what we want to fix, is pointed by the register RBX. If we take a look here, fiber context, RCX or RBX, so let me check. It says that RCX is being set to RBX, so yeah. RBX is where we have our fiber context thing. So I'm going to click here from the first that we can see here in the disassembly to the last one that we see by pressing the key Shift to select everything. And now I'm going to press the key T. If it wants to, give me a second, T. Okay, so in this dialog, that again, sorry, the font for this dialog is very small. If we go to the most last part, we will have here the fiber context T member, struct, that is the one that we want to set here. And again, you are not going to see it properly because it is very small. We have two members here that appears with a red cross with saying that something is wrong here. What we are going to try is to right click here, add missing fields. It mostly works, but not in all cases, and sometimes we need to fix it manually. When it asks, do you really want to modify the structure by adding new members? Yes. Answer yes to it. It will complain many times, we don't care about that. Okay, and unfortunately it did not work. So I'm going to press OK, and we still have the gap 44 here. So what I'm going to do is fix manually. Here we are. We need to undo that, remove that by pressing the key U, undefine, and then we can go back to the disassembler, and here we are. Now we don't have the two that we had before. I'm going to undo these two ones, and pressing again from RBX, click here, from RBX, sorry, click here, and by keeping the shift key, click here to select all these instructions, then press the key T, again as we did before, choose fiber context, and then here right click, add missing fields. And now it will work. Press OK, and here we are. We have the fields that we didn't have before. Let's go back to the pseudocode. Here we are. Now we have proper members instead of things like this one here, gap 19, that we will fix later on. What we are going to do is rename more stuff. So give me 1 second, and we are getting back soon. We are back. So what I did is rename and set the proper type for all the members that I have enough information. So like this one, LP start address, and the data type is the same one that is coming to this function, which is LP fiber stat routine. I didn't want to show all the time me renaming this and setting the type to this so you don't get bored. And now the things that we are going to do is we have some magic values here and some members that we know nothing about them. So what are we going to do? The same thing that we did before with the contextful and all that stuff. Press the key M and cross our fingers, because maybe I don't know something about that and it makes sense. So let's press the key M. We need to choose new and press OK. And IDA says, hey, it matches with mask, whatever it is, and initial mxcsr. And it makes a lot of sense. So we are going to choose this one. And well, we have two members that have the same initialization value. So what I'm going to do is, it looks like the mxr CSR register, so I'm going to name it reg mxcsr underscore the address. Same here. Reg mxcsr underscore 118, the address. Okay, so we have some kinds of information about these two members. More, we have the 639 again. We are going to press the key M and cross our fingers, because maybe IDA knows anything that makes sense about it. And it says initial FPCSR. Makes sense, right? So this is reg FPCSR. Okay, then 43. I don't think we are going to be lucky, but let's try. Press the key M again. It recommends nothing that makes sense to me. Let's press choose a new and search overall, and well, I don't think anything here makes sense for what we are doing. Let me try to search for register something. Maybe it is x64 register high hex mm12, but I'm not very sure. It also says the control status. I have no idea. So when we don't know, the best thing that we can do is don't touch it for now, and eventually we will discover what it is. With 51, I think that we are going to be as lucky as before. So press the key N to try. Nothing that makes sense to me. Choose new. And if we search for register, maybe it is the control status. We saw it twice, but I'm not sure. Or maybe the register effort. We have no idea, right? So for now, we are not going to touch it. It is very likely that it's some kinds of register value, because we already have two, but we aren't sure. More. We have this one. Let's press the key M. Nothing that makes sense. Nothing that makes sense. Sorry. And with this one, the same. We aren't going to find anything that makes sense here. So far, so good. Things that we have to fix. The last thing that we have to fix is this. So we have the fiber context struct, and it is being initialized to 40 bytes in hexadecimal. Is our struct the fiber context T of this size? Because if it isn't, our struct is wrong. Yeah, the members are okay and whatever we want, but the struct must have at least this bytes. Because if it is initializing that struct, it is probably doing memset, fiber context, 0, size of, fiber context T, or whatever type the programmers they use. So let's check it. We need to check the fiber context T struct. So let's go to the structures tab and then choose here fiber context T. Well, if you don't know how to go there, another option is you press, you click over one variable of this type and then click on one member and press the key set. Here we are in fiber context T, and it says that the size is 0x11c bytes. So this is wrong and we need to fix it. The correct size is 40 bytes. Okay, let's copy it, 40, get back here, and now what we are going to do is go to the end of this struct, and we are going to add one new member that we are going to call end of struct. But to do that, just press the key D sometimes. 1, 2, 3, 4. Do you see that DQ? This is a keyword. And now we are going to rename this by pressing the key N. End of struct. Okay. And now the last trick, if we want to call it. Press Ctrl E, or if you prefer, right click, expand extrude type. I always use the keyboard, I prefer Ctrl E. And now it says how many bytes do you want to add to this structure. Well, so we want to add 0x for the 0 bytes, subtracting the current size of the struct, which is 0x124 in hexadecimal, which is that one. And then press OK. In case you didn't know, yes, you can put calculations in the values for either, which is pretty useful, by the way. Okay, and now if we go to the last part, we will see that it now has 40 bytes of size. So fiber context T, at least in size, now is okay, perfect. Let's go back to the pseudocode, and as we can see here, now we have the main set, fiber context, size of fiber context T. Awesome. Let's go back to the previous function, to the one that is calling base initialize fiber context. Either we press the key escape, or here we press the key X and choose whatever xref we want, which is the create fiber X. So more things that we need to fix. We have here one casting, which means that the type of this member is not okay. What is the data type for this member? Fiber context T. So press the key Y and set it to fiber context T. And here we are. The code now looks much better. There are still things like that A4 that we know nothing about, or that V17 that we know nothing about. So we are going to try to discover a bit more. There is one function here, RTL create user stack, that maybe it can give us some information about the things that we haven't discovered yet. Press the key Y, and IDA doesn't know about that. So what I'm going to do is copy the name, the function name, and now try to be lucky and find the function prototype for RTL create user stack. It is very likely that we can find it somewhere. Actually, if we take a look at the very first one result in the internet, in Stack Overflow, we will see this one. So what we see is RTL create user stack, and it returns an empty status, and these are the arguments. Okay, let me copy them. I'm going to go to some here, okay, and fix it here, because IDA doesn't like the in OPT and other things, because, well, these are macro stuff, and IDA knows nothing about this. Let me fix it. Let me fix that. So these are the arguments to this function call. Let me get back now to IDA, and what we are going to do is remove this by default arguments to this function, paste these ones that we found somewhere in a Stack Overflow, and then, as I said before, most RTL functions, what they return is an empty status. So we are going to set empty status here too. Press OK, press F5, yep, and it looks much better now. So that argument is the page size, and that argument is the reserve alignment, and this says that is the initial depth. And hey, look at that, now we have more things that we can modify. So give me a second, and I'm getting back soon. Again, so what I have done is simply rename and set the data types for this new struct members that we discovered thanks to the prototype that we set of RTL create user stack. So now we have, for example, the stack base, the stack limit, allocated stack base. So far so good, many other things. And for example, do you remember that in base initialize fiber context, the last argument, we didn't know what it was? Well, now we know it is initial tab dot stack base. So I'm going to copy it and set here, pvoid stack base. Now, if we get back to this function, now we know that this result with some magical value and stuff is doing with the stack base. What is it doing? I have no idea, but it is doing something with some magical value. Some magic value. Well, I think that now we are really done with these two functions, or better said, with the create fiber function. So what we are going to do now is find more interesting functions and see if any of them gives us more information about how fibers works. So view, open subview, functions, I'm going to put it somewhere here, give me a second. And here, press Ctrl F, fiber, and okay. So this one and this one, we already know everything about them. I'm going to mark them as decompiled, right click over the decompilation, mark as decompiled. And as you can see, we see the color a bit different. We are going to do the same for create fiber because we already know everything about it, mark as decompiled. And then we have base initialized fiber context. And there are things here that we still don't know, so I'm not going to mark it as already properly decompiled. Okay, let's go. Another one, which is going to be the simplest one. By the way, this is how I usually work myself, and this is how I recommend you to do. So I started with the initial entry point, an initial API that I use, create fiber, and then what I do is from all the fiber functions that there are here in this DLL, what I'm going to do is try to go from the smallest to the biggest ones. If we try to go to the biggest ones at first, we are most likely going to get lost at some point, or at least it is going to be a bit harder. It is how I usually work myself, but I can recommend you these methods. So okay, it is very likely that delete fiber is going to be the smaller one. So right click on it, here we are, and well, by now we know that LP fiber is not going to be LP void fiber. Why? Let's get back to create fiberx. What is it returning? So if we take a look, at the very end, it is returning that heap memory that it allocates. And what is that memory that it allocates? The fiber buff_t. So I'm going to change the prototype of create fiberx by pressing Y here. And then changing, it is not going to be anymore LP voice because we already know the prototype. It's going to be fiber buff_t star. Okay? Now let's go to delete fiber, and we are going to do the same. Press the key Y over this argument, this function argument, and send it to fiber buff_t star. And hey, it looks a bit better now. So we have to rename some stuff. Empty current depth we can call simply depth, and then it is comparing with same depth flags that I don't know what are them. So I'm going to cheat again because I already have this flags somewhere and enumeration with the flags that we need. So we are back. So these are the same flags that I have copied from some other place. You can find it in many places in the internet. If you want, I can tell you later. If you want to know where, just write me in the comments and I will put you all the links. So what I'm going to do is simply copy it and add it to IDA as we did before with the pep bitfield t. So let me go here, view, open subview, local types, right click, insert, we paste, we press OK, and if we go to the last one, we will see that we have the same depth flags t here. Cool. Now let's go back to the decompilation, which is here, and now we are going to press the key M here and we will see that it says that saintflask_t, which is what we are going to set here, is dbg has fiber data. So far, so good. Let's press OK. And now it looks much better than before because we have the proper things that we want. So if it doesn't have in the center flag the dbg has fiber data, which is a flag that is being used for indicating that, and the current fiber data for the thread environment block is not this current fiber, it is going to exit from this thread, and then we have a rare thing here. It says jump out. Jump out is when it is jumping out to a basic block that doesn't belong to this function. If we go to the disassembly, we will see that this is a shared basic block in other functions, like for example fls lock. This is pretty common. Some basic blocks might be shared because the compiler decided to share that basic block that is doing the same again and again and again in many functions. So instead of putting that basic block again and again and again in each new function, it simply puts in some shared place and jumps to that basic block that either will say it belongs to one function, but actually doesn't belong to a single function, but to many functions in this database. Okay, and then it says RTL free user stack, and we have the allocated stack base, so we know that it is okay. Then it takes some member and it says RTL process FLS data. Okay, so now we know it is FLS data. Which data type is FLS data? I have no idea, but we know that it is some global variable here with FLS data, so I'm going to rename it. For global variables, I usually put the prefix g underscore. Do as you please. GFLS data. So if it is not null, then it processes whatever it does. I guess that it is for removing whatever it is inside FLS data, but this maybe it's for another video for another day. And then it calls free heap for the current heap and that FLS data. Okay, then it calls free activation context stack with the stack, and then it calls free heap for the process heap and the fiber. So far, so good. And I think that we can mark this function by doing right click as decompiled. So more things that we need. Let's go now to, I don't know, maybe is thread a fiber? So it's always the easiest one, but as it is doing displacements, it looks a bit not so good. So if we go back to delete fiber, we will see that we have the same type flags check against dbg has fiber data. Oops, sorry. So this check is actually the same, but well, it looks in another way. It simply checks that flag. So I'm going to copy this and get back to thread of fiber. And what I'm going to do, because the compilation is a bit rare for me, I'm just going to put a comment. So instead of trying to understand the compilation, I will just read my comments and that's it. So this is one of many ways of putting a comment in a function. Press the K insert. And here what I'm going to do is check if the dep saint flags if it is set in the terminal flags, the value dbg has fiber data. Press OK, and here we have. Now, instead of having to determine what is it doing, set the flags, displacing to the right, we simply check the comment, and here is it, we know it. And you know what? I'm going to mark it at decompile too. Here is it. More things. Now I think that we are going to have to go to more complex ones. So switch to fiber is the API that is being used when you create a fiber to switch to the context of that one. Let's see how it works. Double click. We have the LP fiber, and we know for a fact that the type is different, is fiber buff T star. We know the prototype of it right now. And let me close this. here we have, so it checks the sorted cookie. If it is not the same calculation again, it says, hey, something is wrong here, and it crashes the process by calling fast fail. Otherwise, it calls to switch to fiber context. Yep. So, switch to fiber context, the prototype initially was wrong. When I entered, I discovered that it receives one argument. Then I went back, pressed F5, and now it says, hey, now I know that it is receiving this argument. So what we are going to do is, like we did before, we are going to fix the prototype of this function. Okay, let's go back now to this, LP fiber. And here we have a lot of things that we can rename. So for example, we have this anti-count tip, it is the tip, and now we have the fiber data. So yeah, it is the fiber data. What is in the fiber data? I think that we already saw it before, didn't we? I'm going to click on the fiber data and press Ctrl-Alt-X, or right click, jump to xref globally, and it will show us the global references for that Struct member. So here we have in the lead fiber, and as we can see in the lead fiber, it was comparing the fiber to the fiber data. So what is fiber data? The struct that we already discovered before. So we know for a fact that it is fiber BAF-D. We can actually fix that fiber data type too. And now everywhere where the fiber data is going to be used, the data type is going to be correctly understood by IDA. Okay, now we have this, we have that. Things that we didn't know before, like the D word 518. Now we know that are the warranties stack bytes for that thread environment block. So let me fix this. And this is it. Now we have here some rare stuff that we are going to fix manually. So we have another gap like before, but then we have some variables that doesn't look like very nice, and they say that the value might be undefined. And if we take a look to the comments, it says RDI, R12, R13, R14, R15. Well, it is because it is actually not accessing local variables but registers. Why? Let's see this. So this is the tab, so I'm going to change this. RDX is going to be the thread environment block that I shall have here somewhere in entity. Yeah, this one. Okay, I think. Yeah, entity. So it's not this anonymous thing. I'm going to press Alt and Y and choose fiber data. Okay, so racks, now we have the fiber data. So let's press racks, selecting this, and press the D. And now we are going to choose fiber BAF-D. Yes, yes. And press OK. Here we are. Stack limit, and this is the first part where it shows something wrong, right? Gap A0. Okay, so first of all, I'm going to undefine that gap 0. Then get back here, and we have the fiber context in R8 fiber context. So in R8, what we are going to have now is the fiber context. So let me choose everything until here. Press the KT and fiber context T, because we know this is the data type, and we have a lot of fields that are wrong, and we are trying to fix them. Right click, add missing fields, press yes, and well, we were pretty lucky. Press OK, and now we have them. If we get back to the compilation, we will see that now we can see proper field numbers, field names, sorry, but still we have this thing. What is happening here? Well, it is actually saving the context. What is the context for a fiber? the context is actually all the register values for this thread. So in Fiber context at member 0x19, it is saving the register rbx. So I'm going to rename it to _rbx. This is _rbp, etc, etc. So give me a second and I'm getting back, and we are back. So I already renamed all the members here, and that's it. So it is very good that we have a decompiler, and most of the time I spend right now most of the time when I'm doing reverse engineering on the decompiler, but we need to know how to fix stuff in the disassembler and actually how to read assembler, because otherwise we are going to have hard problems. And well, while we could also fix this here and solve it better, we could, for example, rename this v1 accesses to rbx and stuff. I think that it is much better to do it in assembler, because here it is much clearer what is happening. So in any case, let's now see, and then we have other stuff here. For example, it says the return address, and then we have a call to some assembler instruction. What it means that we need to go to the disassembler, to the assembly listing, to see what is it doing properly and rename stuff. So R9 is most likely the RSP, and this some magical value is RSP, so that one wasn't RSP, sorry. Okay, sorry. Okay, and I think that for now we are already done. So this RCX here is the LP fiber booth. Select OK, and well, I think we are already done. The only thing that we could possibly fix is the pvoice data type here, and we are back. So the other thing is, for example, it calls a return address, but it doesn't look like the return address. Actually, it is R9. So again, we rename it, and now yes, I believe that we have everything that we needed. And well, what is it doing finally? So switch to fiber context is taking the fiber data stored in the thread environment block, and then restoring or setting, sorry, all the values for the current thread, for the current state in the fiber context team. And after that, it is setting the stack pointer to what was previously stored and simply returning. So it is like doing pushing an address in the stack and then returning, but instead of doing that, what it is doing is simply changing the stack pointer. So a fiber is a way, or is an struct, is an object where we have all the context, all the register values and the stack pointer for the current function, whatever we are going to call. And when we do a switch to fiber context, it simply recovers the previous register values. So it simply recovers the previous register values, set them, and then change the register, the stack pointer. This is the almost the last instruction, and then simply do a return. So it returns the previous function that is in the context stack, in the fiber context. Well, so far so good. Basically, I think that we already know how it works, how fibers work. We still have some functions that we might want to take a look to them, which are this one's view of this view functions. Give me a second, I'm going to put it a bit better. Fiber, here we are. So switch to fiber context, I think that we already decompiled it properly. So right click, mark as decompiled. And the other functions that we still didn't do anything with them are switch to fiber. We already have right click, mark as compiled, and then we have convert fiber to thread. Oh, so we can change, so we can take this context, all the registers, the stack pointer that we had for that fiber, and convert it to a proper thread. Well, we can take a look to it, but we are not going to do this in this video. We are going to do it maybe in another one. And then we also have convert fiber to thread, convert thread to fiber. So we do the opposite. Instead of taking a current fiber and converting it, creating a thread for it, what we do is we take a thread and convert it to a fiber. I'm not very sure about why, but well, I think that we are going to take, and well, I think that we are mostly done with this practical video about how to reverse engineer some real target. In this case, now we know how fibers works. We have seen that it well, initialized on Struct. We have all the proper members and the proper data types for test members. And we also know that when it calls switch to fiber, what it does is it restores, well, it first saves the current register values, RBX, RBP, RESA, blah, 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 blah. And then change the stack pointer to switch to the context of that fiber. When we do switch to fiber again, it will do the same thing. Restore the previous context, store, save the current context, and so on and so on. And well, this is it. I hope that you like this video, and see you next time. Bye bye.